to Introduction to R by Professor Charles. We hope you enjoy this video, and if you do, please like and subscribe to the channel. Like C or Java, R is not a programming language. It wasn't developed by software developers for the purpose of developing software. Statisticians instead created it as a dynamic platform for data processing. Because, as you will soon see, the capacity to swiftly study data is a need for success in this discipline. Interactivity is a crucial component of data science. However, you can store your work as scripts that can be readily executed whenever you choose, much as in other programming languages. These scripts act as a summary of the analysis you conducted, which is a crucial component of reproducible work. If you are an experienced programmer, you shouldn't anticipate to adhere to your standard conventions, because you will be dissatisfied. If you have patience, you will learn to value R's superior power in data analysis and, more especially, in data visualization. Features of R. R is open source and free. It functions on all popular operating systems, including Windows, Mac OS, and Unix/Linux. Scripts and data items can be effortlessly transferred between different systems. Our users make up a sizable, vibrant, and expanding community, and as a result, there are many resources available for learning and asking questions. The ability for developers to share software implementations of new data science approaches is made simple by the additions that others can easily provide. As a result, our users have early access to cutting-edge techniques and tools that are created for a wide range of fields, such as ecology, engineering, social sciences, and cartography, to mention a few. The R console, which runs commands as you input them, is typically where interactive data analysis takes place. And R console can be accessed in a number of ways. Simply launching R on your PC is one option. This is how the console appears. R has many benefits over point-and-click analytic programs, one of which is the ability to save work as scripts. These scripts can be modified and saved using a text editor, a terminal for running your code, as well as other helpful windows, such as one for displaying numbers, are all included in the Studio. The editor has several specific capabilities. A pane for editing scripts is offered by the majority of web-based consoles, but not all of them let you store the scripts for later use. Our project launcher for data science will be RStudio. It offers many more helpful tools in addition to an editor that we may use to write and edit our scripts. 3 panels are displayed when you initially launch RStudio. The R console is visible in the left pane. The bottom pane on the right has 5 tabs: File, Plots, Packages, Help, and Viewer. The top pane on the right has tabs like Environment and History. These tabs may change in new versions. Each tab can be clicked to switch between the various functions. You can click File, New File, a Script, to launch a new script. You can begin creating your script in the new pane that appears on the left after pressing this key. Many of the actions we take with the mouse can be replaced by a series of keystrokes. Key bindings are keyboard shortcuts for carrying out specific actions. For instance, we just shown how to launch a new script using the mouse, but you can alternatively launch it using the key binding Ctrl+Shift+N on Windows or Command+Shift+N on Mac. A fresh install of R only offers a small portion of what is possible in terms of functionality. In fact, we call the package you receive after your initial installation base R. The additional functionality is provided via add-ons made by developers. Currently, hundreds of these are accessible through CRAN, and many more are shared through other sources like GitHub. However, R instead makes certain components accessible via packages because not everyone needs all capability. The installation of packages from within R is fairly simple. For instance, you might type, to install the DSLabs package, which we use to distribute datasets and code associated with this book. Install.packages, DSLabs. You can choose Install Packages from the Tools tab in Studio. The library function may then be used to load the package into our R sessions. Library D.S. Labs. You'll see that we only load packages, we don't actually install them. This is so that once a package is installed, it stays installed and simply has to have a library loaded. Until we end the R session, the package is still loaded. If you attempt to load a package and encounter a problem, you generally need to install the package first. If we pass a character vector to this function, we may use it to install many packages simultaneously. Install.packages. See Tidyverse, DSLabs. Take mind that installing Tidyverse involves installing multiple packages. This frequently happens when a package depends on or makes use of functionality from another package. When you use a library to load a package, its dependencies are also loaded. Unless you install a new version of R, you can load packages that have already been put into R without having to reinstall them. Keep in mind that R, not RStudio, is where packages are installed. You should retain a script with a list of all the packages you require for your work so that you can easily reinstall them all if you need to install R from scratch. Using the following function, you may view all the packages you have set up. Install.packages.